And we're back for another AI for all. Hey there, Marco. Thank you.
Hey,
Bits and bolts. That's what it's called, right?
yep, didn't change it.
Yeah. How are you doing, man?
Doing well, better than the last time.
Better than the last time. Why so? What happened last time? I quite
Well,
enjoyed it. What
no, I mean it was great. It was great, but it can always be better.
can always be better. We're always learning things, right? Like machines.
That is true. Somebody had a saying: "You're either learning or earning. Everything else is a waste of time."
You're either learning or earning. Well, the great thing with this merger of Bitcoin and AI, you're doing both at the same time,
Yeah,
right?
hopefully that's
Uh,
the ideal combination.
or our robot overlords are doing them both at the same time, and we'll see what happens to us. I still didn't get the answer of when the robots are going to take over. Maybe we find out today. Maybe we get closer to that answer. But
Yeah, maybe.
I want to go over a few things about the event so far. So just bear with me a little bit. Give me a second. Okay, there we go. All right. As you know, this is the Fedi X Stackwork AI for All hackathon that we're in partnership with Repelit and sponsored by Hivemind, Satoshi, Spirit of Satoshi, Prem, and ZBD. Oh, and I think we also have a new sponsor. This is Lightspark as well. We need to get these graphics updated. So for the event, give me a second. Where is it? I want to talk to some folks just briefly about um, yes, right here. Some of the key dates, as you know, we started on the 1st of July, and the project entries close at the 31st. We've had 2 weeks of educational programs. This week, we're kind of slowing it down, giving you guys some time to build. And during that time, we still want you to build in public, though, right? So it's one of our judging criterias, actually. Let me see if I could pull up that slide. They're so tiny. Mm, give me a second. This is tracks and prizes. I'm just gonna skip through them. Um, yep. Okay. So yeah. How to take part. So even if you are kind of like entering the hackathon now, or next week or whenever it is, there's a few things that you need to do. You need to obviously sign up and register. After you've done that, you list your project. And if you're still looking for people, there's still some people that I know that are looking for teams and whatnot. You can write to them on the Discord or post about it on Bold Fun in the Brainstorms channel. If you have so Bold Fun, we have a feed and stuff. So you post about your idea or say that you're like looking to join up in a team or just comment on someone's idea. There's quite a few projects. People still looking for some teams and stuff there. So what I was mentioning earlier, there's this build in public, right? So even if the pitches are required for the end of the month on the 31st, it's good for you to share your knowledge, share your process. That's helpful for everyone in the community. And that's helpful for people coming into the community if you share, some solution that you came up with, or you just talk about like where your project has come so far. Um, I will show you quickly, actually, um, what that could look like. So you go to, mm-mm-mm. Okay, so this is the feed right here. You go to click create, and you can create a story. You can add your project from here, or you can ask a question. And all those things count towards building in public and stuff. So if we go here, you can see one of the questions that, okay, it's not showing now. Yeah, so you could put a little project update and say, what it is that you're building, or you could do like a weekly report. Just fill this in to let the community know like what kind of progress that you've made. We also have templates for intro there to just introduce yourself to the community. And I think that's about it. That's about it for the housekeeping for me. You can register now. You can still share it with your friends. And happy hacking, everyone. Let's learn about agents now. Let's learn about agents. All right, Marco.
I do have one question about a hackathon, and might be the most important one. Is
Sure.
there like a closing party afterwards?
Well, yes, we will have a closing ceremony. It's actually going to be in San Francisco. Right.
Okay.
Yes, so it's going to be on the 3rd of August, I believe. The date still intact. San Francisco is really, gotten a whole bunch of more excitement these days with like a bunch of people coming back to it. I've been hearing from some VC folks. So it's kind of exciting there for all this AI field and innovation and stuff like that. So there's going to be a party there. Maybe we do something on Bolt Fund as well. We'll see about that. Maybe we do something in this beautiful Belgrade office that we're in for the Hub 21 Belgrade Bitcoin Hub. We'll see. We'll see.
Okay, good.
Yeah. All right. Well, Marco, I'm going to get your slides up there and you'll get started. Yeah.
Cool. Thanks. And again,
All right.
if you have any questions during the talk, please don't hesitate to ask me. It's always good to have like a two-way conversation.
Of course, I'm going to have questions.
So last week we talked a bit more in general about AI and robots, and then we ran out of time, which is fine. That's why we're here this time. And this time we're going to focus more on the actual AI agents, basically what they are and what is their architecture and what are the tools that we can use to make them. And just a brief recap of the previous talk. It was like we were talking about machine learning and neural networks, different types of neural networks for vision, for language, for data series prediction. We talked about different robots and how they operate in real world, how that robotic hardware relies on AI software. And then we talked also a little bit about intersection between embedded platforms, hardware, robotics, and blockchain, especially with Ben, right? And then we stopped at AI agents. And before we actually talk more and in depth about AI agents, in the past few days, we had two very exciting announcements that are worth mentioning here because they'll have impact on AI agents. One is literally 2 days ago or even yesterday, Meta or Facebook released the Llama 2 model. Basically, when Meta released Llama model for the first time, it contributed greatly to the proliferation of all the open source LLM models and agents, and the models that you hear about like Vicuna, Alpaca, and things like that. They're all kind of built on top of Llama, and that was big news for open source community, the first release of Llama models. However, they were not fully open source, or actually they were not open source at all. They were kind of allowed to be used for research, but not for commercial purposes. However, somebody leaked the weights on BitTorrent, and then everybody got the weights, and the rest is history. But this time, they're introducing Llama 2, which is supposedly better, and licenses also more permissible, so you can use it for commercial purposes. However, there are still two limitations. One is that you cannot use it to improve other LLM models, which is, whatever. And then the other one is if you have more than 700 million daily users, then you can't use it in commercial purposes. But 700 million daily users, that's a lot of daily users. And if you have that many users, open source license for Llama is not your issue. So that's one thing. We hope that with this Llama 2 announcement and release, we'll see now even better LLM models. And then the other one is actually Flash Attention 2. So Flash Attention is a method for calculating self-attention in these neural networks. So as I mentioned, these large language models are based on transformers, and a key component of a transformer neural network is a self-attention module. Self-attention module is a very compute intensive. It requires a lot of memory and a lot of flops to execute. And Flash Attention was a successful method of kind of accelerating that computation. And it's embedded in many of these like open source releases, and it allows us to run these networks faster and on the less powerful hardware. But a few days ago, they released Flash Attention 2, which builds obviously on the previous work, and it brings up 2x improvement in speed. So we can expect to see even faster open source models now, or models that are able to utilize memory more efficiently. So this is again very new. So it will take a couple of weeks until we see this embedded in models, but it's definitely exciting. Okay, so we can go back to AI agents. Agent-oriented programming is actually not a new concept, and it has been in the wild since like maybe 30 years ago or so. Somebody proposed the agent-oriented programming instead of object-oriented programming, but nowadays with LLMs, we obviously have much more powerful agents, and it's because of the reasoning capabilities of large language models. And so making more powerful models, AI agents, is a hot topic of research. And I just put a couple of references here on this slide to showcase different type of research. For example, in this upper right corner, it was a team that basically created a small village, and they put AI agents in the village, and they all kind of interacted. Somebody was organizing birthday, they had elections and things like that. It's kind of wild. Then this one with South Park, this was also like from a few days ago. They basically created AI agents, or a system that creates AI agents and then kind of makes a TV show for you, which is very timely with all this Hollywood strikes that are happening right now. And a couple of other papers that basically put different AI agents to interact together to solve problems, to exchange memes and things like that. So hot area of research, a lot of things are happening. So yeah, very exciting. Let's see the next. Okay, so let's see what do we mean by AI agents, right? How are they different than just a large language model? So when we say large language models, it's just a neural network that does next word prediction, right? So it doesn't have any intentionality, it doesn't have any memory, and we can't say that it can do any planning. There's some debate about it, but so far we don't think they do any internal planning. So in order for a system to be agent, it has to have a goal, it has to have like a memory, and it has to be able to use tools and also to kind of loop, or basically loop, right? Because currently when you ask something to GPT, it just outputs the answer and that's it. But agent has to be able to take its own output and then continue working on the task. So as I mentioned, the components are basically a large language model that is responsible for thinking, and then we need to add memory, we need to add some planning methods, we need to give it some tools and some ability to interact with those tools and world. In terms of large language models, we can use any of the available ones, both commercial and open source. Hugging Face is a great resource for all the open source models. While on the commercial side, we have obviously OpenAI, and then we have Cohere and Anthropic. They all have their own versions of large language models with good APIs. Unfortunately, well, it is unfortunate to some extent, the commercial large language models are still ahead of open source large language models, and that's something that we have to deal with. When it comes to memory, so we have two different types of memory, like short-term memory and long-term memory of sorts. So short-term memory is basically just the context that we are providing to a large language model. So for example, if you're asking an agent or a large language model a question, you can provide a context for that question. For example, if you're interested, you want to analyze a document, you can provide text of that document together with your question. So that will be like context, and that would be seen as short-term memory. And that basically that short-term memory disappears, is not persistent. On the other hand, we have long-term memory, which relies on the external databases. And more specifically, it relies on vector databases. So I've put links, I'm mentioning here 3 different ones, like VV8, Pinecone, and Chroma database. Chroma database is most straightforward and easiest to use, and I would suggest everybody to try to use it first and then go to more like complicated solutions. And in most cases, for the non-complicated use cases, you can even just use simple matrices and tensors to store these like vectors. But if you don't want to do that, then just use Chroma. It's a good solution. And so how do these vector databases actually differentiate from regular like SQL databases? So they are vector databases because they store vectors that represent objects. So for example, if you have an image, so you're not, okay, you're storing the image object too, but what is more important is that you're first embedding that image into some embedding space, which means taking the image and transforming it to a like a vector of numbers that represents the image. And we do that with neural networks actually. So again, OpenAI gave us a network called CLIP, which is an embedding network, and it works very good. So you can take text, images, and like, can you take audio and stuff like that? Maybe, but text and images, and you can convert them to these embedding vectors. And then those embedding vectors are stored in the vector database. So how the interaction works is, for example, you ask a question to your large language model or the AI agent, and that question gets embedded into this vector space in the same way the data was embedded the first time, right? And then you have your question embedding, and you have database embeddings, and you run similarity search between the database embeddings and the question embedding. You find the most similar vectors and you retrieve those and you convert them back to the actual data, actual text or images. And then you provide that as the context to the large language model to answer a question. Jones, did that have did you understand that process? Oh, so I can't hear you. I'm not sure if it's me or you at this point.
Oh, sorry, I was muted.
Okay, now I can hear you.
Yeah, there are some questions though. So we have Bitcoin Dad in the building. We also have Python 360. What's up? What's up? So Bitcoin Dad, what's up, party people? Okay, so one of the questions from Bitcoin Dad: can AI agents be paired with SEO, Google, etc., or large language modules that come from interactions from web scraping and stuff? Because when you were talking about the agents, you mentioned about they need to be connected to tools and stuff like that. Would those count as those types of tools?
Yeah, so search is definitely one tool, and GPT had an option for search, Bing search, but it was disabled because there was some privacy issue, or I'm not even sure what was the issue, but currently it's disabled. However, Bing AI, that AI still has access to internet, and it's a very valuable tool because large language models and AI agents are trained on the fixed data set that had a cutoff, for example, in 2021 or 2022. So they don't know anything that happened this year or yesterday. And if you give them access to internet through a search tool, they could search for the information and then retrieve it, put it in their context and answer based on that. So yeah, we can pair our large language models and AI agents with search, and it's very useful to do that.
Okay. And I guess we could talk about how we go from 2021 to more current things later in the talk. I'm sure you're going to cover this one.
Yeah.
So Python 360 mentioned something about SERP API. I'm not sure what SERP API is. Do you know about this one?
I am not sure what SERP API is, but that's a paid API.
Yeah, so building a backend Python API help. Okay, sorry, I'll put it up. Building a backend Python API help bot with live data. Yeah, using the Bing API. Yeah.
So
effectively. So
this is on the left side we have tools, right? And here it says calendar, calculator, code interpreter, search, right?
Oh, so wait, hold on. I think we're on the wrong slide here. Just
yeah, that one. So basically what we need is all these tools have their APIs, right, or function definitions. So we just need a large language model to output the proper syntax for that API or for that function. And we do that by providing the definition in context together with our question. So we tell the model, okay, the API for these tools looks like this, and this is my question. Now you have to decide which tool is best to use, and based on this API description, how to use it. And the large language model will output the proper syntax form like API request or a function call, but we still need to actually call those things. We need to add another step to manually call those things, right? Because large language model can only output language at this point. So there has to be another connection that we have to create.
That's actually going to execute whatever the command is.
Exactly, right. But it can be any tool. So it can be search or whatever. So there's like a very nice symbolic math like library and software Wolfram Alpha, right? So there is an API for that, and ChatGPT can use that. So if you ask it to calculate distances, integrals, and stuff like that, instead of just outputting nonsense based on its training data, it can leverage the API of the Wolfram Alpha to actually calculate the correct things.
So then that gets fed back into the LLM, and
exactly.
I could just never set that. And then the response uses these results.
Yeah. So you pipe back those answers to LLM and say, okay, this is what the tool returned. Continue your whatever task.
Okay. I see how this can get.
Yeah.
No, go on.
So you can do all that manually, or you can have these agents that kind of already have that loop kind of embedded in them.
Yeah, I guess so there is one question that MTG sent me in my DM. He slid into my DMs. I don't know if it's too soon for this one, but after deploying the agent to production, and users are starting to use it, how can we make sure that it's behaving as expected?
Oh boy.
meaning how can we validate the outputs that it's actually making?
Yeah, that's a good question. So the big issue with current large language models is that you never know if they're true or not, the output of the large language model, right? Because those networks are kind of black boxes, and although we know how they work, we know the math behind it, we don't know the rationale and reason why they output something, right? So whenever you ask a model a thing, you don't know if it's true or not, and a lot of times it's actually not true, right? So if you have AI agents that can autonomously interact with outside world, that problem becomes even more pressing, because large language model can start hallucinating, get into some strange loop, and start doing some random things on internet, right? Which we don't want. And right now there's a whole field of AI safety and alignment research that is trying to address this problem. And for example, reinforcement learning from human feedback is one method to kind of align better these large language models and AI agents. But it's a big problem. It's unsolved. So we are trying just to add some external checks and safety checks on top of these AI agents, right? Or you can even have human supervision. I think that actually in one of the previous talks, somebody mentioned that they have a platform that you can use.
Stackwork.
Exactly, right? Yeah, so that would be one solution.
Yeah, so this could be super interesting then. So this is sponsored. One of the people that we've partnered up with to along with Fedi to set up this this hackathon, and it's kind of like the mechanical Turkish kind of thing for. It's kind of like a mechanical Turk kind of system, as much as I understand it.
By the way, I'm not paid by Stack, so.
No. Me neither. Well, am I? I guess I am paid by. I'm a Stack show now. Okay, there we go. At least for this hackathon. But it could be interesting because they have some APIs and stuff. It could be interesting to see what that supervision could be. Those manual processes say hey, please make sure these X amount of results or this random set of results are actually valid or whatever. Someone Bitcoin Dad also mentions create audit bots.
Yeah, that's an option. You can have like one bot that's an action bot, and then you have another one that's kind of a police bot, right? And it will evaluate the actions of this bot and prevent them or allow them, right? Or maybe you can have like maybe you can give like internet money to a bot and say, okay, you to execute any action, you need to put some amount of sats, and based on your confidence, so if you're very confident in your action, you'll be okay in putting more sats, right? But if you're not very confident in your action, you're just going to put like small amount of sats, something like that. I don't know, I'm just riffing here.
That's interesting. But I think at the same time, it can just like it could be any kind of like integer value that like in some accounting system, right? Just say like,
Yeah,
hey,
it could, but it's more fun with
it's more fun with that. Yeah, for sure. The reason I bring up that kind of like vector is because like unless the bot actually values the sats, then for them it's nothing, right? But it is interesting to see
That is
like
true.
to what degree of confidence are you do you have? And the thing about it is that it's not like so far I haven't seen these GPT or anything. Like one of the big problems with it is you ask it for a result and you ask it to like what are your sources for this thing, and it just like it has no relationship to those sources, which is it seems like a big hole or gap, you know. But I guess this is just like very complicated stuff, so it's not able to do that.
Yeah, there was a funny example some time ago where somebody asked GPT to produce like references to some work, to some quote, and GPT just provided some reference, and it cited proper researchers, proper conference, and a plausible sounding paper. But when you like look into that paper doesn't exist, right? So stuff like that happens.
You know, I kind of fell into this like in the early days when I was using ChatGPT. So I would like all my friends, they were saying like, oh yeah, it's not connected to the internet. I'm like, oh well, I was using it early, so I get like it was connected for me. I would paste in a link and I would say like parse this link, or like read what's on this on this link or whatever, and it'll give me a response, right? But then when it like, and it was actually like really good responses, right? I was putting in some stuff from the Bitcoin Design Guide and like checking it out. So they had good slugs there, you know, good URL structure. And then so I read it, and like it's one of the pages that I wrote as well. I'm like, oh, okay, this makes sense. Only to find out later that it's actually just reading the words inside of the link and to coming up with the context. I'm like, okay, so I've been rug pulled the entire time. But I do like the concept of this quality assurance, but as Bitcoin that says, as we're doing like software development, doing PRs and code reviews and stuff, the only thing though is that I feel this is probably the point where the robots start taking over.
Okay, we should talk about that. I see that you're very concerned about it.
I mean, it's the whole reason we do the series. I mean, that's the answer. We go.
Let me just get back to the agent stuff, and then after that, I can talk about it. So the last.
I think it's an ongoing thing, by the way. Sorry, I think it's an ongoing thing for each of these episodes or whatever.
The last point on this slide is the planning. So right now, again, when you ask a language model or an agent, they just output some answer, right? But you can improve the intelligence or reasoning of a model or the agent by using or relying on some of these techniques like reflection, self-critiques, chain of thoughts. So for example, the basic one would be when you talk with your large language model or an AI agent, and I'll just use those interchangeably at this point. So you can ask it to take you step by step through its solution. So instead of just asking a question and expecting the answer, you tell it, okay, this is my question, take me step by step through your solution. And then the model will output, okay, first we do this, then based on that we do that, and finally it comes to the solution. And in practice, it is shown that helps the model work better, right? It's able to reason better, and then that's called chain of thought, right? Then there are different variations on that, so you can ask model, okay, you can do this step-by-step reasoning, but actually at each step produce, let's say, 3 different options, right? So for the step 1, give me 3 different options. For the step 2, give me 3 different options, and like that, right? And then another addition to that is, after each step, actually evaluate your output and tell me if you think that output is good or not. So these are all techniques that can be used to improve the agent reasoning. And then the very interesting, like, and recent paper was, I think it's called Tree of Thought. I think that was the name of the paper. Basically, they kind of paired the large language model and Monte Carlo tree search to some extent. And basically, there was like a module that searches through a tree of answers from that LLM model and comes up with like the best solution of all. But yeah, that's pretty advanced. But everybody can use these techniques to improve their like large language model interaction. So whenever you're talking with your large language model, it helps to set a persona, basically, and it also helps to explicitly ask for reasoning steps. And by setting the persona, I mean, so for example, if you have questions about front-end development, you can say, okay, take a role of a experienced front-end developer that is kind, helpful, and whatever, intelligent. And then you continue with your question. Okay.
I do have a quick question about that. That persona is the simulacra concept, right?
Okay, yeah. So we talked about that before the video, the stream. So when it comes to artificial intelligence, in theory, there are like a couple of different types. So one would be like agentic AI. The other one would be tool AI. Another one would be Oracle AI, and they're all different in how they operate. For example, Oracle AI would be GPT, but if it knew everything correctly, that'll be Oracle AI. So you put a question in and it outputs and gives you back the correct answer. So that's called Oracle AI. Then Agent AI is something that can interact with the environment and has its own like agency and desires and goals. Tool AI is kind of similar to Oracle AI, but more narrow. So it's a like perfect tool for some task, right? And then another type of AI is actually a simulator. And what that AI does is simulate other things, right? And there's an argument that GPT and large language models are simulator type of AI, where they internally can simulate real world and personalities. And then when you ask it, okay, take a role of a software developer, it kind of creates a persona, creates simulacra of that like developer. And for the duration of that context, it will behave like that front-end developer. So LLM is a simulator, and when you ask it to take some role, then that entity is called simulacra. That's just a hypothesis at this point. I'm not sure if it was like officially proven or accepted by the larger AI community. Definitely interesting.
It's very much in the territory of philosophical stuff, especially with the simulation part of them.
Let's see. What do we have next? Are we okay? So this is basically how one version of an AI agent works, right? So this specific scheme is for the Baby AGI, which is one of those open source AI agents, and we can see what are the different like steps in its like finite state machine. So basically, a user provides an objective or a task. That task is put into a queue. From there, it's taken up by some agent or large language model. Large language model tries to like execute that, or if it can't, then it creates subtasks. Those subtasks are then put back in a queue, and we have another like AI model that prioritizes those tasks, and then the top priority task is again sent to the execution AI, and it runs in a loop, and it also has some memory. And all AI agents are more or less, well, all of them are some variation of this, right? It can be like how many these separate AI agents we have, how this memory is implemented, things like that, but this is the main principle behind it. And okay, so when it comes to to Jones's main question, when will robots take over? So there's a couple of scenarios how it can happen and when it can happen. Not everybody is on board with these ideas, but I do think there is some merit to them. So obviously there's like a sci-fi scenario of like Terminator stuff, like super AGI just killing everybody, but you don't have to go that far into the future, right? So let's say you have this Baby AGI, right? And Baby AGI has like access to the tools. It has access to like APIs of different software. It knows how to code, right? And you can just tell it, oh, just I don't know, just go crash a financial system, right? Rob a bank, and based on its capabilities, it will actually do that, right? At some point. So that's a real risk, right? You have a completely autonomous agent that runs much faster than humans. By run, I mean like operates much faster than humans, and you give it an objective, and it just starts working on that. And if it's sufficiently capable, it will be able to do damage. So it can be either because the objective is malicious, like rob a bank or overthrow a government, or just because agent does not necessarily care about same things that humans care about. So it can, in the process of doing some task, some objective, it could negatively impact some other areas that we as humans care about. So that's likely to happen, actually. So I think that these AI agents will be used for bad purposes. And there was actually news from a few days ago, or maybe even yesterday, that hacker community created like something called Worm GPT, which is like an open source GPT version that was fine-tuned on phishing emails and malicious code. So you can use it to produce better phishing emails, and I think maybe even create some like some malicious code, right?
So you say So you're saying that they created a spell check?
Yeah, spell check, right?
I mean, a phishing email. That's a big component of it.
So
We
Bitcoin
got
Dad
it.
has a bunch of questions actually.
Yep. Is it possible to host your own AI agent using open source and GPT-3 or 4?
Yeah,
Lessons learned?
definitely possible, and I'll actually go into some tools for that later on. But yeah, it is possible to have like your own dedicated machine and your dedicated agent that you set up. You can rely on APIs from OpenAI, or you can use open source model that actually run on your own hardware. So that's entirely possible. And then the other
Another
one
one
is
is quantum computing. Ooh, okay. This
yeah. So quantum computing goes above my pay grade. I think that we're still very early on in that technology, but at some point, I hope it will mature and be useful for humanity. It does
and
hold
for
a lot of
phishing
promise,
emails.
at least what people are telling us, right? So we'll see.
And for phishing emails as well.
For phishing emails, yeah, just imagine the phishing emails that you'll be able to create with a quantum computer.
I mean, like it depends on like if it's fly fishing or if it's like open water. Like it really depends because I'm like more like open water, salt water kind of guy from the Caribbean and stuff. So really depends what kind of emails. But I'm really happy the hacker community is interested in fishing so much. You know, as pescatarian.
So when it comes to quantum computers, what they're supposedly good at is optimization problems, and training a neural network is a huge optimization problem, and it takes a lot of time. So to train GPT-4, it takes like a couple of months on like thousands of GPUs, and maybe quantum computers will be able to speed up that optimization process, right? That's one promise of quantum computation. I'm not sure if those algorithms exist and how feasible that is, or rather, right now it's not feasible at all. But in the future, it should be. So yeah, that's my take on quantum stuff. Okay, so this is Baby AGI. Any AI agent works on a similar principle, just different components. And this is just a link that, so the whole person, Jones, I'll give you the presentation afterwards so you can maybe like attach it somewhere, maybe to YouTube stream, or I don't know, to a website. So people can take all the links and all that stuff. AI agents are just one example of applications that use large language models, but there will be many other applications for these large language models. And this slide just gives a kind of conceptual architecture of LLM app stack. And if you go to the source article, there's a lot of links and references to tools that you can use for each one of these components. It's a very useful reference article, and I encourage everybody to check it out if you're interested in building LLM apps. Okay, so some tools that you can actually use to build these apps. Currently, one tool that's very popular and it's often in the news is LangChain. And LangChain is, well, they call it like a framework for developing applications powered by language models. And it is basically that. It's a framework, Python framework, that you can use to string different language models with the databases, with tools. So it just provides a wrapper around and syntactic sugar around like different like low-level code. There was recently a controversy with LangChain because a lot of people came out and said, okay, LangChain is not a good library in terms of like software development. But it can be useful depending on your use case. You can use LangChain and rely on it. The other one is Llama Index. So LangChain is basically framework for building apps, LLM apps, while Llama Index is more specialized on connecting different data sources with your large language model apps, AI apps, right? Because we talked about memory and data and how you can bring that data to your LLM. So Llama Index helps with that. It's basically a connection between your data stores and your large language models. And then in terms of like LLMs, the best place to look for them is Hugging Face. They're an awesome company, and they contributed a lot to proliferation of AI. And then you have closed source solutions, most notably OpenAI, Cohere, and Anthropic. In the bottom row, I just added like 3 different AI agent like services: Super AGI, Agent GPT, and Baby AGI, and each one of them is kind of open source. But I think that the easiest way to use them is to just use them with like your OpenAI API key, right? So they'll call your OpenAI GPT. And Jones and me actually tried this a few days ago, and I'm sad to report, but they just don't work that good. So we were experimenting with the building a CMS system, right? And we gave it access to a repository and asked it to build a CMS system for it. And what it did is like create some code, and then it actually wanted to delete all the existing code in the repo, which was a disaster. And it kind of submitted the PR for that. I was like, no, this is like not good.
So that's exactly how the world ends. Right? It's like, hey, I want to build a CMS. Okay, delete the world, and then the only thing remaining is a single computer with a CMS on it.
Yeah.
Like,
So basically, yeah, that's how the world ends. So I think that. Oh yeah.
So there's a question here. Are all of these require building an API to link the front end to the agents, or do some of them do it all under the roof? And I think you have some stuff for that as well, right?
So these
So it's about the front end.
Yeah, I'll mention those tools later. But Super AGI, Agent GPT, and Baby AGI, they're like services. So there's nothing you have to build for them. You just provide your API key for OpenAI, and they already have their like memory and loops and everything. So they'll just try to execute a task. But if you decide to build your own app, then yeah, these LangChain and Llama Index, they're like backend tools. So you would need to build your front end on top of this. Does that answer the question? I'm not sure.
Yeah, well, I think when you get to that other part, it will be because I'm interested in hearing about that.
Okay,
so that one as well.
This is also a good distinction in LangChain. So they have a couple of primary, I guess, objects or whatever they are. One is chains and the other one is agents. So the difference is that a chain in LangChain is basically a deterministic sequence of operations. So you can, and this is actually also related to something with Lightning Labs, what they released recently. But yeah, so chain in LangChain is literally a chain of deterministic operation where each step in the chain can be either like, oh, use this API or use this large language model or just do something, right? It doesn't need to have any actually AI in those steps. So that's a chain in LangChain. While the agent is what we were talking about, like AI agents that are able to use different chains, use different tools, and kind of have some agency. when you start working with LangChain, you'll see the difference.
Yeah. Okay. So this distinction here, I just wrote it up, probably badly. A chain in LangChain is a deterministic sequence of operations where each step in the chain would be to use like an API
Yeah.
or
Yeah,
etc. Right? But an agent, okay, so agent is a superset of the chain. Okay, so an agent could use a chain, it could use an API, it could use an
Yeah,
LLM
exactly.
and choose that,
Yeah.
but it could also use multiple chains that it might have.
Yeah.
Gotcha. Okay,
Okay.
that's fair.
So what?
I feel I'm getting so smart. I'm getting like, oof.
Okay, so this was also something that we talked this morning here in the Bitcoin Hub Belgrade. So when we have these foundational models, large language models, they're trained on internet, right? Literally all of the internet books, Reddit and things like that. But what if you have your own use case and you want and you have like your own documentation and data that is specific to your own company or whatever, right? And right now, obviously, these large language models don't have access to proprietary data, so they don't have any knowledge about it. And if you do want a language model that kind of has knowledge about that data, there's two ways to do it. In-context learning and fine-tuning. So in-context learning is something that we talked about in the scope of the short-term memory. For example, if you're a law office, let's say, and you have terabytes of like legal documents that are specific to your office, you can provide those documents as needed into the context of the large language model. So you can put them in the vector database, you can index them, embed them, and then you can retrieve them from that vector database as needed and provide them as context to the large language model question. That's one way to do it. That doesn't require any modification to the large language model, but it does require adding the database and vector embeddings and things like that. That's one way to do it. The other way to do it is actually to fine-tune the large language model. And what that entails is that you take your data, you kind of prepare it for the training, AI training process, and then you take the existing large language model, either closed source or open source. Closed source only if they offer the option of fine-tuning. But you take that large language model that is already trained on all of the data, and you kind of train it a little bit more on your proprietary data. So it will not forget anything. Hopefully, it will not forget anything that it learned before on the general data set, but it will learn few new things from your proprietary data set. And in this case, you are actually modifying the network, and you do require some training process that relies on like optimization and things like that. I think OpenAI has a nice and simple API to do fine tuning, so it should be straightforward to do it if necessary. And if you want to do it on your own, then Hugging Face is again your friend. They have their library for transformers, and it's straightforward to do fine tuning with it. Did that make sense?
Yeah, so far so good for me.
Okay.
For everyone else, oh, we got some shout outs there. Yeah, well, Python 360, you gotta thank Marco here for dropping all this AI knowledge on us, because I'm learning just as much as you are.
Okay, so this is actually a slide with different tools, right? So many people are just using cloud LLMs from like OpenAI, as we mentioned, but there are alternatives to it. So you can deploy your own large language models. You can take a Llama model and deploy it somewhere. So you can deploy it on traditional cloud providers like GCP, AWS, or Azure, right? That's one option. The other option is to use more like specialized cloud providers that mostly offer like endpoints, so it's very easy to spin up a GPU with the deployed large language models, and you can use like Mosaic ML, Replicate, and even Hugging Face. They have that service, so you can go to their website and say, okay, I want to run this open source model on this GPU, and you provision that basically instantly, and they provide you with the API endpoint that you can just interact with it. So that's very straightforward to use. It can get expensive, but it is what it is. And then finally, you can run some of these models on your own PC, even Macs actually. So there are ways to kind of slim down these large language models so you can quantize them. So instead of using 32 bits to represent numbers, you can use like 16 bits, 8 bits, or floating points, or maybe just integers. That's one way. Then you can kind of distill big models into a smaller models. You can prune the models. Anyhow, there are different techniques to do it, but yeah, we can make large language models to run efficiently on small hardware, and you can run them on your own GPUs and servers. And you can look into Llama CPP. That's a pretty cool library that provides basically models that can run efficiently on your own hardware. Whisper CPP is related to Llama CPP. It was made by the same person, which is now a larger open source movement, but it all started from a developer, I think, in Bulgaria. And while Llama is a large language model, Whisper is actually audio to text model. So Whisper was an OpenAI tool. They open sourced it, and then people made Whisper CPP, which runs efficiently on your own hardware. And then another option is a diffusers library from Hugging Face. Again, it has a bunch of models, and some of them you can run on your PC, like for Stable Diffusion, things like that. So different options. Legacy cloud providers, new AI-focused cloud providers, and then you can run on your own hardware too. Okay, this is the UI part. So many people who work in AI field don't have a lot of experience with building front end, and we usually actually work in Python for some reason. Well, for a couple of reasons, that's the preferred language for developing and researching AI models. But if you do want to make an app or a UI for your application, then you can rely on some of these tools. Both Gradio, Streamlit, and Reflex are open source libraries that allow you to build user interfaces quite quickly, and they're tailored to machine learning applications. There's some differences in how they operate behind under the hood, but it's not that important. It's just important that you can use them to very quickly make a UI for your app. And by very quickly, I mean literally just minutes, because they already come with pre-made components like text boxes, sliders, things like that. You just kind of need to arrange them and string them together, and you get a nice UI. Reflex is slightly different in a way that you write your Python code, and then actually it compiles your Python code into JavaScript code, which is kind of cool. And Reflex is most flexible between these three. So I would say Gradio is least capable, then Streamlit, and then Reflex. But as the capability increases, the complexity of building stuff with it also increases. So you just need to choose the right tool for the job. You can ask ChatGPT to make the Streamlit app from your Python code. Yeah, you can even do that. I think that right now you can go to bard.google.com, right, their AI model, and I think that somebody basically, you can upload pictures to that AI model, and it can analyze pictures. So somebody made a sketch of a UI, gave it to Bard, and asked Bard to produce like code for that like website, and it did give some code, allegedly working code. So yeah. However, I don't think that these large language models are on the level of human coders, experienced human coders. The code they produce is oftentimes not great, but for simple things, it's super useful. Sure. I don't. Do you have more time? It's already like 10 minutes.
It's we should finish it off. I don't want to
Yeah. So
stop this.
I actually
It's too
this
valuable.
is the end, right? I wanted to mention the Lightning Labs tools that they released a few weeks ago. One is like this. They call it LangChain Bitcoin, but it's two different tools. One is called Bitcoin tools, and one is this tool related to the 402 protocol. And what it allows you to basically, Bitcoin tools is what we talked about, right? It's a instruction on how to use Bitcoin wallets and interact with blockchain. So you can provide this, as we can see. Oh, sorry. So this is using LangChain, right? So here in LangChain, we initialize the agent, and this first line where I said Bitcoin tools, it's where we kind of provide the tools that AI agent can use. And then when we ask what is my current channel balance in Satoshis, large language model will know how the API for those tools look like, and it will be able to output the appropriate commands to use those tools. And yeah, in this case, it just outputs the result of whatever it finds on the chain. The other tool, yeah, so this is like tools that agents can use to interact with the blockchain. And the other one that they released was this chain that's specific to the L402 protocol, which is the protocol to request payments, Lightning payments, right? So if you use this chain, then this chain enables AI agents to interact with that request. So you'll get the request, chain will trigger one operation, then trigger another, and then finish with the payment to the server, right? And this is just an example how to use it. Again, using the LangChain library. And in this case, yeah, there's some service was behind the Aperture server, and it required a payment, and this chain recognized that there's a payment necessary, so it executed steps for that, and then LLM was able to like access the data behind the paywall, basically.
Yeah, and that can be for another agent, or it can be for like the weather or whatever.
Yeah, it can be anything, literally. Yeah. Mm-hmm. And that's the end of the presentation.
All right. Very, very interesting here. Same thing with Python 360 and Bitcoin Dad. Yeah, just having these concepts clarified and stuff like that, it's so valuable. I feel like I've jumped forward in my knowledge about the space and stuff. And I know we're helping put on this hackathon and stuff, but I'm definitely not as up to speed with things in the space, and it's moving so fast too.
Yeah,
I did want to.
Fast. That's for sure.
Yeah, I did want to show off a couple things. So this is a dashboard for this product called Prem AI. They're one of the sponsors as well for Tracks, and I'm not just saying this because I'm shilling, because I'm a paid shill. Okay, relax. I might be a paid shill, but besides that, that's what paid shill's supposed to say, right? But for those of you who are who are in the Bitcoin space, you know about like Umbrel, self-hosting, and those kind of things. This is basically kind of like a Umbrel style thing for LLMs, right? So you install it on your own machine or on a server, and then now you're able to just install one of these models that I don't really know too much about. What they are. There's also some chat interfaces and stuff for them. So let me show you, for an example, GPT for all, Laura Q4. No idea what that is. You might be able to give some more context, Marco. But yeah, you could test it out. When are the robots going to take over the world? All right, just let's see. And well, yeah, I'm sorry, I cannot answer that question. Okay, I see.
So there is
Well,
actually one distinction that is useful to know between. Can you go to the model page?
Okay.
So you see you have MPT7B chat and MPT7B, right? So difference is in how the training for those neural networks is finished. So MPT7B is just a large language model that was trained in a self-supervised way to predict the next word, while the chat options are usually options that had like reinforcement learning from human feedback. So basically, they were instructed and encouraged to be more conversational, while these base models are just next word completions. So for some application, it's better to use these like base models, or obviously for chat applications, it's better to use chat models. And then
I see.
7B, 12B means like a number of parameters in the model, 7 billion parameters, 12 billion parameters. And then Q4 means the level of quantization.
What?
So level of quantization, basically optimization to run those models more efficiently. It's just a method of optimizing those models. And LoRa is also something that you don't need to pay too much attention to.
What's it like the V2? What's
the V2? Yeah, V2 is V2. I don't know. Just a second version of that network. But yeah, the main distinction is between chat and base models. So just have that in mind when you use them.
Very interesting. Okay, that's So is this like a common naming convention, or people just name it whatever they want?
Chat, it is. Yeah.
Okay. And the Q4 and stuff like this as well?
Q4 is also like, but you'll not see that often in the models. I think you'll just usually see like chat and no chat.
Super interesting. Okay, even getting to read, because like that's one of the things you look at, like how do you choose which one, right? So at least if I see something that says like 100B, then I'm like, oh, maybe I want this one, or maybe I don't. Maybe it's too big. But okay, dude, knowledge dropping. Thank you so much, Marco, in the building. There's one other example just before we go. Since someone asked about so this is like the self-hosting version. You could self-host like on your local machine or on like on a VPS. Or if someone seems to be coming. And then the other one that I want to show you as well. Oh, hey. The other one that I would like to show off is this Langflow. So Langflow is this UI for LangChain. So I haven't gone into it as yet, but yeah, I'm super interested to see how this works here. It allows you to construct these chains and use the components in LangChain, and then you can interact with it through this chat UI. So it seems like a nice, cool development kit, basically. All right. Well, folks, that is it from me and Marco. Marco, I would like to thank you so much for dropping this knowledge. Throw some orange hearts in the chat for Marco there. Marco, really, thank you so much. Hopefully, you have time in the next week, so maybe we get to continue this. I would love personally just to have these conversations with you, share it out in the open for everyone else. Because I think it's super valuable, and that's what we try to do: building in public, sharing the knowledge, learning in public as well. And yeah, thank you so much, Marco.
Bye.
Yeah. Oh, and I guess one last thing: you can follow Marco at let me pull it up. What's the Twitter? Simich VM.
Yes.
Yeah.
That is correct.
So at SIM, it's VM. Yeah, and you're pretty much there everywhere, right? Simich VM.
Yeah.
So follow
Every
Marco,
social
follow
network is
Marco
the same.
on Twitter and all the other socials. Thank you so much, everyone.
Nostr too.
Nostr too. There you go. Ciao, ciao. Thank you. Thanks so much.
Bye.